to do new stuff. Stay. Okay.
Yeah. What's up?
All right. So most everybody went around. Some of you guys just forgot the second step in this problem. The first step in this problem is just, what the hell vector is this? So I'm just making what's called linear combinations of vectors, which is really just to push it a little bit. If I give you two non-collinear vectors and I make all the possible combination of those vectors, I get a plane. All right, I'll stop. Do you have to know that for this? No. But what do you get when you do this to those vectors? What did you get? What vector did you get? 7, 10, 0. So that should be relatively easy, right? Just take u and you subtract. So multiply this by -2, multiply this by 3, and then add all those up. And then the length is what I really need. It's going to come into play here.
Root 149.
Root 149. I like it. All right. Sounds like road trip time. I took root 149. Thank you. I liked it. It was good for just for me. So I talked about this. If I want a certain length in a direction, I want to create the thing that only has the direction as information. Its length, I want it to be 1. So it's like a blank slate as far as length is concerned. So I want the direction of this weird thing. So I'm going to take this thing divided by its length, its magnitude. I like it. So now I've got, this only has direction information now. Its length is a blank slate, it's 1. And I want it to have length of u, and what's the length of u?
35. Root 35.
Root 35. So then I just multiply it by root 35. You can bring that in and bring that in. This is one place where I might be okay with you not rationalizing this. You understand? At that point, it's just, an exercise in big nothing. So you can bring that in. That's the answer. You construct a direction vector. That's kind of like my own wording. But it's a unit vector that has information about the direction of another vector. So why don't I just call the damn thing a direction vector? Yes?
So you're saying on a test that would be an acceptable answer format. What it needs to...
Yeah, so I'd want you to do this. This is the vector answer. And rationalization on this thing, I would just be like, screw it. That's the vector, that is the answer. I like it. This is sort of like a problem to work out to get the answer. That's the vector, that is the answer. How are we doing? Yes, sir.
Can you write the vector as root 35 over just like some constant times
So again, it's sort of like if a student told me the answer to some simplification problem was 2 times 3. And I'm like, well, that's not enough. You're not done. So if you have a coefficient in front of the vector, you should bring that in. Now, is that always true? No. You can kind of play around with that. But for right now, the question says, give me a vector. So don't give me a constant times a vector. Give me a vector. Is that a huge deal? No. You see what I'm saying? If you would have told me the answer was 7, 10, 0 with that over that out front, I would have just made a little note. I wouldn't take points off. It's not a big deal. Okay? I do want to sort of make that point. That is the vector answer. This is a problem that hasn't been done yet. All right. And then I take a step back from this weirdness, and I just give you something direct. This is beautiful, right? I mean, hopefully everybody in here realizes how awesome this is. What's that going to be?
0.
Yeah, so in general, especially for this one, because, oh, yeah, that's right. That's why I put that there. Because then it comes into play later. Okay, sorry. So it's -6 plus 1, right? Plus 5. So you get 0. I love it. So dot product, if I'm given the component form of the vector, it's easy as hell. You gotta love that. Cross product, yeah. Something to do with hell for cross product, but it's different. This one is a little bit freaky, but I really... The process, again, remind me, what's the process to get the angle? It's the inverse cosine of, so I want the angle between A and B, let's say.
A dot B.
A dot B?
Over the norm of A and B.
Yeah, divided by the norm of A, the norm of B. So now, I really want this to make sense. if I want to figure out the angle between two vectors, if I double this vector, will the angle change? No, of course not. So if I say the z-axis, some of you guys are like, what the freak? I want any vector that is in the direction of the z-axis. Any vector, because it doesn't matter what the length is, because what's this process do? Divide by the damn length. So if I use a unit vector in the first place, that kicks ass in a lot of ways. Right? Or we just use the most readily available vector if it's not an axis. But if it's an actual axis, dude, use I, J, or K. So what are my two vectors for this problem? That's going to be U
And 0,
and good. 0, 0, 1. That represents the z-axis. The easiest way to represent the z-axis is every multiple of that. You get the z-axis. So now you just apply that process. So what is the dot product of those? What's the dot product between those? 5. Gotta love it. Hopefully you're soon to the point where you can say it that quickly if you're not quite there yet. But dot product is component, 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 add the products of those. So if I got a bunch of zeros, that kicks ass. It's going to just pluck, that's going to pluck out the z part of this. Because that's the basic idea of dot product. What part of this lies in the direction of this? The z part. Yay. And then the length of this is 1. So I just need the length of this, which we did already, yeah. And then you just got to plug that in a calculator. It's incredible. I mean, before this class, if somebody said, how do you find the angle between two lines in 3 space? You know, like, Google? But now, the process is like, I love this because it's so easy. It's almost impossible to believe that it's that easy because we developed these funky ideas of dot product. Why are they useful? Hey, that's almost all I got to say, but I'm not done saying why that's useful, but that's a pretty damn impressive one right there. Okay, so what do you get, sorry? 32 point? Sure, whatever, blah, blah, blah. I might say how much to round to, but if I don't, 1 or 2 places normally is good. These will go out 7 places. All right. Now, how do you read this correctly? This question. Yes, the projection of W on U. I'm making a big deal out of that because my teacher, when I learned this, did not make a big deal out of that. And we're all like, how the hell do you remember where to put what? But if you just realize, you say W on U. So what direction will the answer lie in? U, because it's W projected on U. If you say it correctly, you understand how to set it up better. So how do I set this up?
U dot W divided by the
Yeah, so it's definitely going to have U and W in it, and it doesn't matter which is on which. That's going to be there.
and then magnitude.
divided by the magnitude.
Divided by the magnitude of U. Now, real quick, how do I know that's not the whole thing?
Because
What type of answer is this? What level of answer is this? Yeah, scalar. And the answer for a projection is the vector. What would this be? That's the what? Component. I love it. I love it. I love it. Oh shit.
So you multiply.
You multiply it by what?
You have
U hat. I love it. So it'll be U divided by the length of U, because I want it in the direction of U. Do you see that idea of, that's why I like to write it like this instead of pulling that over, making it U squared and all that kind of bullshit. I see length, direction. That's what I need to see for vectors. That's what they have to have. Yes, sir.
For D, you multiply the U dot product of two vectors. Could you just say that by the fact that the cosines of each one of those, like if the unit vector, if you take the direction cosines of each one.
Oh, we basically just did the direction cosine.
Yeah, but could you say, do you have to do the dot product? If
The-
I showed you the dot product of what?
So here, the direction cosine, the formula for the direction cosines have the components for the axes that I'm talking about. Why? Because the dot product would be just that component. Remember, this was like A1 for the direction cosine with the x-axis alpha. I don't know if you guys remember this at all. You guys are like Did we talk about that? I tried to make the point that the direction cosine discussion is almost a silly discussion because you just do the same damn procedure. It's just easier because there's going to be more zeros involved, right, for the axes. But it's the same procedure. I didn't even talk about direction cosines with this problem, but you're right. That's what we did. We did the direction cosine. It's going to have the z component because I want it with the z-axis. Bam. So you could just say direction cosine, not even worry about the dot product, but it's not like you're wasting time. It's not a hard dot product. Sorry, but you're right. Okay, so that's the first few. Any questions on those? If you haven't done the homework with these, that's why you're not familiar with them.
Yeah, if you just do the cosine gamma.
That's what it meant. That's what we were talking about. Exactly.
Yeah, but don't you need, isn't that the inverse?
So no. So
Cosine gamma, is that
this guy is defined to be the, how do I say it, like the z component, A3. Right, the z component over the length of, A, right? Times the, and that's, and so I can take the inverse cosine. Yeah. And which is, what we did. We didn't even think of it that way, though, because that's a specific example of this general process. So to me, I try to weed out everything that makes it seem like there's more. Like, remember in pre-calc, shit? And I don't know if you remember this, there were like these half-angle formulas and then power-reducing formulas, and if you look at it, it's the same frickin' formula, just solve for a different part of it. Why memorize both of those as if they're both different things? So I'm not going to make space in my brain for this, to be honest. I know what they mean when they say direction cosine. I know what I do. That's the important part. If I said find the direction cosine, find the alpha, the direction cosine alpha, you'd have to know it. In this case, it would be gamma. Thank you for that. Write gamma alpha for the x, beta for the y, gamma for the z. So if I said find this, you have to know the process to use. You have to realize that you have to use this. Or even just use the component in the z direction. That's the only thing I worry about that you know. But if I said if I said this, you don't have to think about this at all. If you don't want to, you could, but there's no need. All right. I don't know if anybody got what I just said, but it's all right. All right, so let's look at the next part of this. F has a meaning in a name and all this stuff, but right now it's just work to do. But it actually has a geometrical interpretation. So we'll get into that today, maybe. Scheisse. Scheisse. All right. Why did I take my vectors away? So I want U cross W dotted with V. Little side note. If I said to do this, let me let everybody catch up with me. You have to be able to look at this and not even waste any time doing it. Cross products require what kind of inputs? Vectors. And this would be so like the man said, meaningless. Completely meaningless. There's nothing here. I like it. Cool. This is fine, because what do dot products require? Vectors, and the output to this is a vector. Okay, good. I like it. Doctor. Sorry. So it all depends on the way you want to do this. Personally, I kind of always do it this way. You don't even need to draw that, but oh well. What was U again? Oh, I got it right there, Jeff. Look at you. Good job. Always, I don't know if I've said this specifically, but if it was W cross U, I would put W first. If you realize what that does, it just flips everything, just changes the sign. Because the cross product is going to be perpendicular. It could either be pointing up or it could be pointing down. That's really the only options it has. Given two vectors, to be perpendicular, it's got to be up out of that plane or down on the other side of that plane. There's only two possibilities. So put that one first. And then what's the other one? What is it? W. Cool. And then just repeat it. This is sort of the shortcut, so you don't have to memorize that whole freaking thing. All right, the 2, 3 minus 3, 2. Oh, God. But there was a good point. If you had to go into 4 dimensions, this actually doesn't work. This is just a coincidence for 3 dimensions and 3-dimensional matrices. It's actually a semi-coincidence that it comes out to be the formula we need. So we just appreciate that. So what do I get here? I get, I don't know, did you guys do it this way?
No.
Some of you guys did, some of you guys didn't. Did you do it the formula way?
Yeah.
Okay, so let's see if we get the same thing. So then what would this be? 1 I, 0J, 9K. I like that. And then this way, if I do this way, I'm just off a little bit. Oh well. 0K. Is that cool? 15 minus 15I, right? All these are minuses. That's plus, 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 minus, minus, minus. So minus 15I minus negative 3J. And then, where am I at? You get over there. Stop. 0K. I like it. So you should get negative 14I. Let's put this in order. 3J, 9K. Is that what you got? Is that what you got, Christian? I'm sorry I put you on the spot. You could just say yes.
Yes.
But if it isn't, you can tell because who knows? I might have made a mistake.
I got that.
So what you got?
No, but I don't trust myself. So.
I did. I got that.
Did you do it the other way?
I did it the other way.
Okay.
With the U2 W3 minus U3.
Okay. Just to make it feel worse.
Great.
I mean, there's so many, to me, just to let you know, some of you had me before, you know this is true for me, it's still true for this class. The concept is much more important to me than little mistakes. I know you don't think 2 times 3 is 5. I have certainly done a mistake like that in my life. Doesn't mean I don't know math, it just is a verification that I'm still human, right? Please let me still, I bleed. So, what I'm trying to say, when I grade, if you can show me you know what to do, then I'll give you more points. So I might take a point off if it becomes important or something, or if it's something you should notice. On the level of algebra, when they said build a shed and it was negative 8 feet long, I'm like, what kind of material is that? Don't you too close, you get sucked into the black hole material I've used. Sorry. Negative length of the shed. It's like, don't go there, man. You never get your shovel back. Oh, sorry, I'm not done with that. What was the next thing? So now that's this. How do I write that component form? Not too bad, right? How do I write that component? Negative 14, 3, 9. And I want to dot that with V. What was V?
Negative 2, negative 1,
1, 1. Like that? Negative 1, 1? Okay. Yes, sir.
How'd you get negative 15?
I don't know. Negative.
It's 1 minus 15.
Yeah. I'm minus 15.
No, the numbers are right.
Okay,
Yeah.
you just subtracted.
No, yeah, sure.
Okay, sorry.
I added
That's
them,
all.
but the 1 was negative. Yeah. Right? When you do this way, so 3 times 5 is 15, but then you subtract because I'm going that way. That's all
Got it.
subtraction. I like it. So if you want to use this shortcut, you have to kind of understand these are positive, these are negative. I like it. I enjoy it. Okay, cool. And then this, of course, would just be what?
28.
28
Plus negative.
minus 3 plus 9.
Is 34.
34. Cool. I like it. Yes, sir.
I have a question on this too. When do you know when to use a sine theta or cosine theta?
Oh, hold on. Let me get there. Sorry, I'll get there. Real quick word about the triple scalar product is what this is called. Obviously, we call it because there's 3 parts to it, and the answer is a scalar. It's crazy. So we say, what do we call it? Triple scalar. Okay, sounds good. What it ends up, what represented, in fact, this has to do with part G. What represents the area of a parallelogram defined by 2 vectors? Well, how do I find that? What represents that?
The length of its cross product.
The length of the cross product. I love it. This ends up, if you do all the math and you calculate all the sines and cosines and you draw it in 3D and you see the, remember the idea behind this? Why was it a dot product? Because I need the true height of the parallelogram, and that involved doing a cosine to get the true height of the parallelogram. I'm sorry, not cosine, sine. So if I want the true, if this is theta, I haven't drawn this all that great, but if I want the true height, I'm going to have to use sine theta to get that height. And that's built into the cross product's length, so that's why this is the length of the cross product. If you do this and get all the angles involved, you'll notice that 3D, it just captures all the true heights and the true whatevers. And that's, you end up with what's called the volume of this three-dimensional parallelogram analog, which is called a parallelepiped. So this is the volume. Can you, no, Jen, you can't spell, just pretend like you can. Volume of a parallelepiped. Cool. Yes, sir.
Is that when you have a parallelogram and you kind of extrude
And
it
you
out
just
diagonally?
repeat the parallelogram. Yeah. So you have a parallelogram, and you repeat it. That would be a parallelepiped. Pretend like it's drawn well. Pretend like somebody else drew it. Screw it. Don't look at it too much. Yes.
Does that mean this formula thing is like you can put the
Yes. So you can actually prove. I like it because real quick, just to make this would be like the vector. It doesn't really matter, but just to make it equivalent to this, this would be like U and W, and this would be V. So if I do U cross W's length, don't I get the area of the base, the area of the parallelogram base? And then I dot it with V, and it somehow picks up the rest of it. It's neat. It's neat. It's neat. Because a true height would involve, again, a sine, and so if you did all of it, it would come out to be that. And you can prove that you can change. I should be able to say, well, I can get the area of this parallelogram, which would be, what's the area of this parallelogram?
U dot V.
U cross V's length, but when I dot it, it does pick up the length, dotted with W. So there are several different iterations of that are equivalent because of and I can reason that out because of what it represents geometrically. I can prove it also with components of this shit, right? All right. All right. So this one is a lot nicer. We just got to find we can either do this, which a few people did, but what is that equal to? What's the length of the cross product? It looks very much like the dot product, except it has a sign in it. So it'll be what? So what's the dot product is magnitude U, magnitude V, cosine. So what's the length of the cross product? Magnitude V, sine. So some of you guys did this and then took its length, and some of you guys found the angle and then did this. I don't care. Whatever you think of, because they're both equivalent. Not just by definition, actually. By computation, they're equivalent. We proved that they're equivalent. I started here and I worked my way back there. Okay, good. So it's not by definition, it's by computation. So, okay, Jeff, what the hell do you do? I don't know, shit. So if you wanted to do this way, how would you find the angle between these two? We have a whole process for the right. Inverse cosine of the dot product divided by the magnitudes. No.
And then you just plug that angle.
This would be to find the angle.
Oh, sorry.
Yeah, that's right. Please, dear God. I will sometimes confuse them. Even though I understand them, I will still say sine when I mean cosine. So always double check. But that one I want the cosine because I'm using the idea of dot product to help me get this. Because I don't want to do this. And I can understand if you're like, I don't want to do that. Well, you got another option. Involving the dot product, which is a lot easier to work with. What is U dot V? We had to do that already, didn't we? Didn't we?
Oh yeah, it's 0.
0!
Oh yeah.
Isn't that kick ass? And what's the inverse cosine of 0?
Yeah, it's 1.
90 degrees.
1.
90 degrees.
Oh.
I'm not saying what's the cosine of 0. I'm saying what's the inverse cosine of 0. Yes, sir.
That's number 2, right?
Where am I at? Oh, no, I'm sorry. We're in G. We're in G. All right. So you got to realize this is a multi-step problem. You're in frickin' Calc 3. You got to there's going to be quadruple, quintuple step problems. Just deal with it. So I found the angle. Now I can use this to actually answer the questions. Right? So this would be the length of u we had to do earlier. What was it? Square root of 35? Is that right?
Yeah.
Can't believe I remember that. What's the length of v? Did anybody do that? Square root of 6 times the sine of 90, which is... So when is cross product, given two vectors, how do I orient them so the cross product is the biggest? Given two vectors. I can let you turn this one around. How would you orient it so that the cross product is biggest? Make the angle between them 90. Where's sine biggest? At 90. So, but what does this make the dot product become? 0. I love it. So dot product is biggest, of course, when the angle is 0 between them, and then, of course, cross product goes, what the freak? And it goes 0. All right, I like that. Kind of makes sense because one's based on cosine, one's based on sine. It's crazy, yeah. So whatever that is, I like it. Now let's do number 2. Shit. This was useful. Do you guys agree this was useful?
Yes.
But I was worried this would happen. I wanted to do a little new stuff. We'll see if I can still sneak some new stuff in there. So number 2 actually is not like harder than any of the ones up top. I just gave it to you written in a weird format. And I could even feel free, but I probably wouldn't. This class we're normally going to deal with R2, R3. Linear algebra, which some of you have taken already, deals with R anything.
Rn.
Rn. I love it. Right? Not registered nurses, but any dimension. Sorry. So U is U3. And I won't do this unless I make a mistake, but I normally give you IJK. I can't remember if the book gives you like IKJ. It's just evil to do that. You gotta go, oh, they put it in the wrong order. Just look out for that. V, negative 11, 1, negative 4. And the process, we do this so much, it's got to become part of just your makeup, your physical being, is this process here, right? It's going to be the dot product. Now notice something real quick. I want you to notice something. That over that is a univector. That over that is univector. So notice how it's sort of like the direction of U and the direction of V in a way. Right? I don't mean to put a dot there. Sorry. I saw your face and I'm like, oh yeah, shit. That wouldn't make any sense, right? Because it needs vectors. Okay, but you guys see there's several ways to look at this, and actually that relates to an idea of this, but I won't go further. So now you just got to figure what is the dot product? Dot product kicks ass.
What is it? It's the amount of difference between the two.
I like it. So what is it?
Negative 21.
Oh,
Negative 33 plus
negative 21.
12, right? Yeah, so negative 21 over...
The square root of 4,002.
Sure. Oh, you multiply the two?
Yes.
So like it's 9, 25, 29,
130.
and 121,
38.
38, and blah, blah, blah. Okay, just plug all that in, and you get what is the angle?
109.4.
109.4. Now, I love the fact that somebody did the cross product. I don't love it, but it's good in terms of instruction. Because cross product has a sign. You can just take inverse sine. So the two things with that make it difficult. One, cross product sucks. A little bit. I don't really mean that, but compared to other things, it definitely is worse. Secondly, what's wrong with inverse sine in a way that inverse cosine does not have the same issue?
You're positive and negative different quadrants. Sine is positive in 1 and 2, cosine is positive in 1 and 2.
So the output of the inverse sine actually ends up being a what kind of angle? A reference angle. So you got to be careful. When you get the negative, there's something that's going to actually, or even a positive, it could be a reference angle for the second quadrant, right? Or whatever quadrant, but the second one. Yeah. So that's the answer for the cosine. If you do the cross product stuff, you actually get 70.6, which is the reference angle for 109.4?
For G, so the answer is just the cross product of U and V.
The length of the cross
The
product.
length of the cross
Yeah.
product. Okay.
Is that cool?
Yeah.
So you could have, I didn't do it, but you could get the cross product and then just apply the length, and you
Okay.
should end up at the same place.
Yeah.
Yes, ma'am.
When you said the inverse cosine of that over there, was that unit vector of U and unit vector of V?
But see, I was not quite that because I was kind of ignoring the dot, right? But still, it's just a kind of a way to remember it a bit. No? Yes. It's just nice. You can see like unit vectors. It's not really because this is connected with a dot. It's not exactly that, but still, it's nice to kind of see that in there. Makes it easier to remember. Okay, maybe. Maybe not. I don't know. Yes?
What are you gonna label that as? Is that the length?
Yeah, that's the length. Yeah. I mean, I don't need to label it because that's what that means. I like it. Cool. Okay. Yes, sir.
Okay, for, let's say for area or any equations like that, can we just use the magnitude U cross V? Or do you want us to use UV sine of theta?
Oh, no. I'm sorry. I did it this way because of the fact that we already had this dot product.
Okay, so we're
You know what I
using
mean?
general-
But if I had nothing, then either one of these ways might be equally difficult. So you can just pick either one you want.
Just pick fastest approach.
In this case, I had what I needed for the angle of the dot product, and then the angle was beautiful. So why wouldn't I do it this way? Yeah, but you can totally do it this way and have the same answer. Take S. Bless you. Okay. So just to let you realize what we have done, we basically finished 12.4 except for one mention of some properties of cross product. The last thing